Hi, this is Tom, and in our last video, we talked about, or we saw that as the number of compounding periods per year increased, the amount of money you make on the same interest rate increases as well. So, in this lesson, we are going to learn about E. And the question is what would happen if we could compound our money more than 4 or more than 10 or 12 or 50 times in a year? Let's see what happens. So, the title is E, and the problem is this. Invest $1 at 100% interest rate, compounded n times per year. Now, really, 100% interest rate? Well, that's a good interest rate. So let's do this. We're going to make a little table here. We're going to make a little table, and we're going to track this to see what happens. So first off, notice that our formula is, we'll say some amount is equal to the principal that we invest, this is what we said last time, times 1 plus the interest rate divided by the number of compounding periods raised to n, which is the compounding periods, times t, which is the number of years for which the money is invested. So I'm not going to use the dollar sign, we'll just have to remember that. But notice in the problem that we have, our amount, A, is going to equal, our initial investment is 1, times 1 plus our interest rate is 100%. But remember, 100% is the same as 1. So I have 1 divided by n raised to the number of periods, n. And we're only going to do this just 1 year. That's all you get for this great investment. It's just 1 year, so it's n times 1. Or we would simply simplify this to 1 plus 1 over n raised to the n. So here we go. Let's see how we do. So we're going to do our keep compound here. Compound and money. Or how about A? How much is it worth? So we're going to try a few of these. And you're going to need a calculator, and I'll do some of these calculations with us as well. So here we go. If we start compounding this, let's start it annually. So if you compound annually, that's just once. So you go, your A is going to equal 1 plus 1 divided by 1 raised to the 1. Well, that's simply 2. That's not too bad. I can handle that one. Now, let's compound it semi-annually, meaning twice a year. So if I compound semi-annually, this is going to be 1 plus 1 divided by 2 raised to the second power. This is going to give us 2.25. And it's from here on out that I'm going to need a calculator. So what if we compound quarterly? Well, that means 4 times in 1 year. So we have 1 plus 1 divided by 4 raised to the 4th. So let me see if I can do this more gracefully this time. I'm going to switch over to my good grapher calculator. And let's try this. We're going to take parenthesis 1 plus 1 divided by 4 parenthesis raised to the 4th power. Whoa, look at that. 2.44140625. Wow. So if I could invest quarterly, I would definitely do much better. So let's write that down. That's the same as 2.44140625. So wow, we're definitely doing better. Let's compound this monthly, once a month. Let's see what happens to our $2, or to our $1. So that means 12 times in 1 year. 1 plus 1 divided by 12 raised to the 12th power. So we would go back here to our grapher. We're going to take 1 plus 1 divided by 12, parenthesis, raised to the 12th power. Look at that, 2.613033529. Wow. Okay, it looks like it was definitely worth getting monthly compounding. So let's write that down. 2.692596996954. And if we had a bigger, if our screen continued out, we'd have even more decimals. So let's put dot 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 after these. And what about weekly? I wonder if we'd make more weekly. Well, weekly, there's 52 weeks in a year, so 1 divided by 52 raised to the 52nd power. Oh my goodness, this is going to be a money maker, I tell you. So we would do this again, and I used my calculator, and I came up with 2. Oh, I'm sorry, I wrote this wrong. This was mistaken. Sorry, that one should have been... I miswrote. This monthly was 2.61361303529. And if you do it weekly, then you get your number of 2.69259 6954. And this goes on and on and on, and each one of these does. So the question is what if you continue this out to each day, each hour, each minute, each second? And you should try those and see what happens. But what happens is kind of interesting. You don't keep making more and more and more and more money. At some point it stops. It reaches a limit. And that limit is if you were compounding infinitely compounding, the number that you would reach is what we call E. The letter, and it's represented by the letter E, and it is a decimal that never ends. And let's take a look at it. I'm going to go to my good grapher here, and your calculator usually has an E button, and here mine does. So I'm going to type E, and then let's just press enter and see what it gives. And here, this is, let's see if I can just copy that. So this number here, 2.718281828, it goes on forever, and it never repeats its pattern. It's a non-repeating pattern. That is the decimal approximation for the number E. So let's go back to where we were, and let's try this. I'm going to paste it in there. Hopefully it'll paste. Doesn't look like it wants to, but we can write that down. 2.718281828, and it just goes on and on and on. And that is where they arrive at the number E. And in the next example, or next lesson, we're going to take a look at how E is used when things really are compounded infinitely. Thanks for watching.